It was reported that Statistics 2 students had improved their scores on average by 5 points. 5 students were randomly sampled. Then they show us, for these 5 students, their score for Statistics 1 and their score for Statistics 2. And so this is a paired sample because each of these rows is representing another person. And for each person, we've got a pair of data points, their score for Statistics 1 and their score for Statistics 2. Assume that the grades follow a normal distribution. What conclusion can be drawn at a 10% level of significance? Okay. Let's set up a null hypothesis that the difference between the scores is 0. And our alternative hypothesis, let's see, would be that the mean difference ends up being positive. And by that, I mean that the Statistics 2 scores are higher than the Statistics 1. So I'm going to compute my difference this way. Okay? So our first step is going to be to put this data set into list 1 and this data set into list 2. Go ahead and pause the video and get yourself ready for that. Okay, so once you've got your data into your two lists, it should look like this. And now over on list 3, I'm going to define it as the difference that I'm interested in, which is list 2 minus list 1. The improvement from list 2, from Statistics 1 to Statistics 2. We would find it by subtracting in that order. Now it's showing us those differences. It computed it for us, and then we go from there to the stat menu, tests, and we want to do a t-test on the data that's in list 3. So here we're going to go back to 0. We want the data in list 3, and let's see, we want greater than 0. That's what we're testing. And go ahead, like usual, choose the draw, and it's now going to compute for us the t-statistic and the corresponding p-value. And there they are. So let's jot those down. I've put those over here in red. So what does this mean? We go over to the level of significance in the problem, 10%, and we compare our p-value to the 10%. Is it smaller? Yes, 0.06 is smaller than 10%. So in this case, we're going to reject the null hypothesis. We have statistical evidence. We have statistical evidence to claim that the scores are higher. Scores in Statistics 2 were higher. At a 10% level of significance, we can say that the way these results came out, it would be pretty unlikely for this just to happen on the basis of chance alone. And so we're going to use that to claim that the scores in Statistics 2 are higher. And we could say that actually in a more precise way. Remember, this is a paired t-test. So we're going to say that students who took both courses, did better on average in Stats 2. So we are rejecting the null hypothesis and accepting the alternative hypothesis that the average difference is greater than 0, meaning that the scores in Stats 2 are higher than the scores in Stats 1 for each student. Students who took both courses did better on average in Stats 2 at a 10% level of significance. That's it. Ta-da, we're done.